Number 18. Two tracking stations are on the equator 205 miles apart. A weather balloon is located on a bearing of north 41 degrees east from the eastern station and on a bearing of north 71 degrees east from the western station. How far is the balloon from the western station? On your answer, the nearest tenth of a mile. So I'll start kind of plotting this out. It says two stations are on the equator 205 miles apart. So there's 205 miles, and I did this horizontal because the equator is horizontal. There's an east station, and there's a west station. It says a weather balloon is located on the bearing of north 41 east from the eastern station. So what that means is this. You'd start looking north, and then we turn 41 degrees to the east. So that would be 45, so it'll be less than 45. We'll just say it's there. So that's 41 degrees there. And it says the other station is north 71 degrees east. So again, you're starting north, and then you're angling from north 71 degrees to the east. Now, if everything was drawn perfectly to scale, this would be 71 degrees and the other 41 degrees. Now it says how far is the balloon, and this is our balloon here, from the western station. So we're looking for this value. Round your answer to the nearest tenth of a mile. So here's what I'm going to do. I'm going to look for, it's not a right triangle, so I cannot use psi y cos x tangent is y over x. It's either going to be law of sines or law of cosines. I'm first going to determine what kind of angles I have in here. This angle is easy to find because these two are complementary. So 71 or 90 minus 71 would give me 19 degrees. I got that angle. And here, that's a right angle, and this is 41. So I could determine that this whole thing would be 90 plus 41, which would be 131 degrees. Knowing that, we can now determine this angle. 19 plus 131 is 150. So if I take 150, or excuse me, 180, and I subtract the 150 from it, I get 30 degrees. That's this angle here. If I have all the angles, I can use law of sines. Law of sines is on the formula chart up at the top of the front page. We have it here. And so the law of sines would say you take the sine in the completed set, which is angle 30 over 205, and you set that equal to the set you're looking for. We're looking for this side length, so I'd use 131 because that's across from it. And we'd cross multiply and divide. Now, I know you can use insolve if you so desired, but I'm going to write out the algebra here. So I would have x times sine of 30 degrees equals 205 times sine of 131 degrees. And then finally, that was cross multiplying. Your last step is you would divide this by sine of 30. So I'll type that in the calculator and let's see what we get. So we had a fraction here, and it was 205 times the sine of 131 degrees, and this was divided by sine of 30 degrees. And we get 309.43. So here we have that x is equal 309.43, and our unit is in miles. And that would be our answer.